We are at gotomath.com and we are looking at what are we looking at here? Oh, I didn't know I could do that. Learned something new today. We're evaluating limits analytically, and we're looking at this particular problem here. We got the limit as x approaches -3 of 3x squared plus 23x plus 42 over x plus 3. So the idea here is we're going to do the direct substitution, taking the -3, plugging it in, and I'm just going to tell you we're going to end up getting 0 over 0 here. And that means that we need to try to factor and probably factor the numerator, cancel out some like terms, and then do the direct substitution. So let's bring up a board we can draw on, and I guess we'll use whatever color comes up here. So we got the limit as x approaches -3 of 3x squared Is that right? Is that the problem? Hold on. Hold everything. Yeah. Okay. I think I was looking at something else. 3x squared plus 23x plus 42. So if you follow me throughout all the topics in calculus, I will assure you that you will definitely have a good understanding of calculus, and your grade should improve. Or maybe you're just wanting to learn calculus on your own and you're not actually associated with any colleges or high schools. We're just out to learn calculus. As a matter of fact, I think that #1 man up there on well, anyway, he should probably go to my website and learn some calculus. I'm not going to mention any names. We want to factor. Let's factor. Let's just do that. So you know factoring is like a puzzle, right? It's like a puzzle. Let's factor the top. 3x plus 14. Now I know that it's going to be a 3x. That's a given. But the 14's not so obvious. And then this is going to be an x. That's a given because 3x times x is 3x squared, right? And then we have a plus 3, and that's not obvious either. However, if you've been working some of these problems, you go, oh, well, there's an x plus 3 down here in the denominator, and probably going to be an x plus 3 up here in the numerator. And I mean, that is a clue. And if we take the -3 now and plug it in, you can see we get 0 over 0. But let's just go back real quick here. We got 42, and kind of what I did was, well, I know that 6 times 7 is 42. And then I completely factored this into its prime factors. We broke it completely down. So let's see. It could be 2 times 21. In other words, this could be a 2, a 21, or it could possibly be the other combination, 14 and 3. As you can see here, 2 and 7, and then 3. 14 and 3, and that's what I end up getting. So I look at this, multiply, and then break it down into its prime factors, and then just kind of look at it from there, right? So hopefully you know how to factor. We're not going to get into all that. We can rewrite this limit. I guess I need to move on pretty quick here. We've only got 5 minutes. They say 5 minutes. Your video shouldn't be any longer than 5 minutes. That's what the experts say. Alright, let's cancel out the like terms there. Let's rewrite this limit. Now, of course, I should be writing equal signs over here because this is still all equal to each other and equal to the original, right? And then we have 3x plus 14 is equal to, now we can get down and do the direct substitution, plugging -3 in. I should probably put that 3 over here, and then plus 14. And what do we got? We have -9 plus 14 for 5. It looks like 5. Let's go back, and of course I got a help button up here, but not all the problems have the help programmed into them like this one does. Let's factor, cancel like factors, then do direct substitution and simplify. So just like you've seen me work